And we're live.
Hello, everyone. Welcome to today's LFE webinar. This webinar is about programming. We'll be introducing a microbit, a versatile microcontroller that can be used in various activities in programming and electronics in the classroom. In order to be more precise, I'm very happy to introduce Vinicius Oliveira, my colleague at Nucleo, and who will be the presenter today. And because programming is a very fascinating activity from pre-primary to upper secondary, I strongly believe that today's presentation will have ideas for everyone watching throughout Europe. Vinicius, the floor is yours.
Okay, thank you. Hello, everyone. So it's really a fascinating theme about talk about programming and of course microbit here. Let me show my screen. Yep. I hope everyone it see. It's okay.
Yeah.
So this is the short presentation about the webinar for today. And this image here, it's a simulation from Microsoft to microbit. Okay, it's only to start about it. And of course, my name is Oliveira from Nucleo. Thank you for everyone be here. Okay, what is the microbit? We have this image. I take this image from the website, the microbit website. And the idea, it's a microprocessor programming. I can do a program in a website specific we'll use soon, and use this device to do something. In fact, it's possible to do many things, a lot of amazing things to do. And this device, it's a physical one. I have one here. You can see in my hand. So this is the microbit. So it's really small. It's really micro, you know. So this is a microbit, the device we use today. And this image I can show you is the original microbit, the version 1. Okay, the version 1, it's simplest, but it's amazing. It's very powerful too. What we have here, we have a USB connector. It's a micro USB. I know it's a little bit old today, but it's a micro USB. Here in the front, the image of the front of a microbit, we have 5 to 5 matrix of LED. It means 25 LED lights. Here, it's possible to be some output from your program, your code. You can do information for the user, using this LED. We have 2 buttons, the A button in the left and the B button. It's really button. You can pull this button. And it's possible to programming something. For example, if you press button A, you can have a smile face like this image here. Or if you press button B, you coding, you program the button B to clean up the LEDs, turn off all the LEDs, for example. It's possible to do all these things. And this device is possible to connect this guy in another device, another electronic device, more powerful, or I don't know, LEDs and sound meters, something like this. And to do this, we have 3 ports name it pin 0, pin 1, and pin 2. It's possible to program all this pin 2, of course. And we use this guy to connect for a LED, for example. How will you see? How will you see these things? And we have the pin 3 volts. It means the positive. It means the positive. The 3V, it means the energy from the microbit to all the circuits you want to use. And of course, the ground, the negative, the ground, D and D. And this pin, it's the ground. This is it. The idea to use a microbit like this is useful for the kids, for the students, because you have the programming part. The people love programming, for example. Oh, it's perfect. I want to code something. And the same way, we have electronic parts. You have the electronic device. It's possible to connect another electronic device and touch the situation. Programming, and after that, see directly how it's work. So it's really, really amazing, this microbit world you can see. And okay, this is the front, and the back is the side image here. The back, we have a processor. This means the part more important for understand, for programming, it's the processor, of course. And here we have a compass and accelerometer. It means it's possible to use the direction of the microbit to make a compass, for example. If you import for north, it's the LED mark north, an N for north. If I change the microbit for, I don't know, west generally it's like this. It's possible to use this compass here to understand now the microbits change for west, and now the LED mark west, a W. It's possible. It's really possible. It's easy. In fact, it's really easy to make a compass using microbit. And we have a reset button. If you have any problems, press the reset button, and a battery socket here, because the microbit needs energy. It's always possible to use the computer, to connect in the computer with the USB connector and have energy like this, or a bank, or energy bank. Or of course, using here this socket, it's possible to use batteries. Okay, this is the general idea of the electronic of microbit. What is the original one? The version 1. Now we have the version 2. It's similar but have more details. You can see the difference here. It's not only the color. The color, it's random. You have the color in green like this one, and blue and red and so on. It's random. But the point, it's the microbit version 2, the new microbit. We have more device inside the microbit. So the difference is now the logo here, it's touchable. So you can use like a third button. You have A button, B button, and touch logo like a button. It's touch. It's not but a physical button like A and B, but it's possible to program this touch and logo to do something. You see something like this. Now we have a microphone here. The microphone, here it's the indicator in front, and back we have really the microphone. And now it's possible to measure something like sound in the space. It's possible. Or of course, this microbit, it's not so smart, if you can see. to understand the language. Okay, it's now for now we can do a program to understand the language, understand what I said here or there. It's impossible, but it's possible to understand the tones of a sound. You understand the change of the music, for example, and use this to control something. So the microphone is for this, okay? And in the same time, we have now in the back a speaker. It's not a really good speaker to hear some beautiful music. It's like a 8-bit speaker. I know many of you never heard something about this, but if you play a long time ago, I don't know, Super NES video game. So the speaker, the sound is similar of that, or the first is cell phone, not smartphone, before the smartphone. The sound is like that. Okay, so it's good. It's possible to, I don't know, to play do re mi, something like this, or Ferry Jacques. It's possible to understand these musics. Okay, but it's not for do the music, do the sound to understand something. And for me, especially, I really love this new device inside the microbit, is the radio antenna. So it's very amazing to use this radio antenna, because you can connect many, 2, 3, or more microbits in a place. Of course, you have a range to the target. I think it's something about 8 to 10 meters, the range, okay? But it's possible to connect a microbit another to send some message, some signal, one for it, using a radio information, because this radio antenna, yeah, it's possible, because this we can use for many things, to play a game or so on. It's really amazing to do this. And of course, this is the difference from the original and the new microbit, okay? And it's possible, everyone noted, you have the pin 0, 1, 2, okay? But we have many others small pins here. Yeah, it's true. We have this small pin here. And the idea is to use this to connect more devices, you see? But the idea it's impossible to connect directly, so it's necessary an interface, an adapter to use this. And using this adapter in a microbit, it's possible to have 20 pins. And each one, it's possible to program it to do something. This is the point here. Programming the electronic device to do something I want, I need, okay? I will stop to share, only to show directly the microbit in my hand. So it's this microbit I have here, it's a version 2, the new one, okay? It's possible, probably it's not easy to see, but you have V2 here, okay? And this is the microbit, the pin 0, yeah, 0, 1, 2, 3V, and ground. And to use the other one, I need a connector like this one. It's a connector, adapter, and I put the microbit here, like this, and now I have more than only 3 pins to programming. I have 20, all these guys here. Of course, this adapter is to use in a proto board like this one. And of course, this is electronic now. You mean, this is the point. You can use an electronic and coding, both it's important to use a microbit. Okay, it's not the point here right now, but the idea, I connect in a protoboard like this, connect the protoboard. Now I have a structure, complete structure to use electronic device named microbit. But before this, the more important now, it's programming this guy, something. After that, I use the electronic to test my program. It's a good practice do like this. The first you think about it, and after that you code the situation, code what you want, and then you can test. And sometimes the test doesn't work very well. You need to change something in the code, something in the programming, but the general idea is like this. And just because I will share again my presentation here. The good place to start programming a microbit is this place, makecode.microbit.org. It's for free. It's not necessary to do a login, but it's a good idea. It's for free for Microsoft because the microbit it's a project from BBC and Microsoft and so on. So the Microsoft has this platform here named MakeCode, microbit, and using this guy, it's possible to programming in the same time. It's there are many tutorials to begin the microbit work. It's possible to use the tutorial in many languages. Here it's in English, of course, but you can change the language here. You can go there and change the language for many. Probably it's not all the language of the world, of course, but many of them. It's possible to change to Portuguese, to Germany, or I don't know, Spanish, of course, because we have many Spanish speakers in the world, and Russian, it's possible, okay? So it's really, really important. In fact, once here in Portugal, I did a workshop with Microbit, and we had a student from Ukraine here in the school, and this student doesn't speak Portuguese very well, and it's impossible to read Portuguese for them, for him. And in this case, he changed the language for Ukrainian, no, for Russian, because it's from Ukraine, but speak, okay, no problem about it. And use it, the microbit, with the partners, with the colleagues in the school. And the teacher said me it was the first time this little guy participate with the group, because speaking in English sometimes with them, but it's not the original, the fluent language for him. So the microbit is good for internationalization of a group, of a classroom too. And if you start a project, you click here in new project. Every time open something like this, you need to put a name, and after that start of these two guys here. The idea, the idea to program this, it's using blocks. This is very powerful way to programming, to coding, because in this case, it's not necessary really know a language. And a language, it means a computer language. So it's possible to change here. It's possible to see a JavaScript or Python. It's possible too. You can code in Python, code in JavaScript, and work with microbit. It's perfect. It's not problem here. But if you want to use this guy, microbit, with a child from 10 years, with 10 years old, maybe, probably, This little guy doesn't code in JavaScript or Python. Or code, I don't know. But usually it's not there. It's not usual a guy with 10 years coding in JavaScript or Python. But in blocks, it's really possible to learn really fast. You understand the logical behind the coding, behind the programmation. This is the point. So, of course, show this for you. It's easy. The idea is really directly there and see working this guy. So I have one here. Oh, I'm sorry. I need to share my screen again. Okay. So this is my count here. You see my name here, my photo, my profile, and it's okay. Again, it's for free. It's an excellent price for me, for free. I love this one. And the website, it's make code microbit. It's possible to put directly in Google, for example, make code microbit. The first usually is this guy. Okay, so the idea, it's possible if you want. It's not today, but another day you can start here. You see the tutorials. You have many tutorials. Is the easy one, something more complex here. Okay, it's possible to see. Use clap your heads to something. It's necessary, of course, the V2 and many others projects we have here. But the idea here is to start with the webinar 1. I just created before. It's here. So in this page here, in this site, what I can see in the left, we have a simulation of a microbit here. You can see the simulation of microbit. And the right, we have the blocks to program. Of course, I can change to JavaScript if you want, or Python. I prefer Python, of course. But it's not the point here. Today, it's block. I change again for block. Okay, it's here. Block. Okay. I don't know why do this. So this is the block. Usually, when you start, we have 2 blocks, on start and forever. It means anything I put inside the block on start will run only on start the microbit once, okay? And anything I put in the block forever will run all the time, forever, okay? The name is directly, and run many times, okay? Let's see. For example, show an icon here, like, I don't know, a small face. See the simulation, a small face on the start. In this case, we don't have anything more to do, only small face, a smile face, only smile face. So smile face is like forever, but I can change this on start smile face, and after that I said hello, it's good. So the idea, I start again, I start the simulation. You see, be attention, the smile face, it's only for 1 second once, and after that the string hello forever, okay, forever and ever. Okay, so restart, smile face. You see, it's really fast. Okay, smile face and hello. So I can change this because the the smile face is really, really fast. You can change. We have a pause here. And put a pause, 1 second pause. Again, the smile face for 1 second, and after that, hello forever. Because the hello, it's forever. You see, the idea is direct like this. You have a block on start. It means run once on start, and after that, never more. And a block forever, and the block forever runs forever and looping in eternal, in forever looping. Okay, this is the point here. So the two things I have is not only these two things. I have many others in the input. It's the point here is to understand what is the middle. Again, in the left, I have the simulation of a microbit. In the right is the space where my programming, my code is. In the middle, we have many information, many things, many blocks to use in my program. This is the point here. So if I want to change my programming, so I said it's possible to press the A button. The A button, it's an input. So we go in input is this, on button A, press it. On button A, press it. What I want when a button A is pressed? Maybe show a number. I don't know. The number 100. Okay? So the idea is smile face, hello forever, hello forever. It means, and I press button A. After the hello, 100. After that, go back to forever. Hello, 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 forever. You understand the point? So if you want something in your code to be forever, to be run every time forever, the point is forever. See, the sound is directly. This is the strange of the coding by blocks. It's directly. The point is directly. So a kid from 10 years old, it's possible to understand this directly. I know some kids with 80 years old understand directly this situation and change the programming to do something directly. It's good. It's amazing. And the point is, another thing, if I press the button A, this information, this code will be run only after the code before it's finished. It means the code before it's hello forever. So the name hello finished. After that, it's possible to put the button A. And after that, come back to forever. Okay. We can have the button B too. Oh, it's the similar button. So the color marks something wrong because the button A it's already done here. Oh, okay, no problem. I change to button B. And now if I press button B, what's happened? I don't know. You can put a different something. I don't want to use the advanced, not now. The sound maybe doesn't work very well here, but it's possible. Okay, I just show something in the LED. Something like a capital V. My name is Vinicius, so capital V, you know, understand? I know, I have problems here. Okay, What's the program here? On start, only on start, once I have a smile face. After that, forever, hello. If I press button A, show the number 100. If I press the button B, show the capital letter V. Let's start. Again, smile face, hello. Hello. And A, after that, B. Finish hello, button A, 100, button B, capital V. It's very quickly because it's necessary to make a pause if you want to see better. 1 second. I think it's possible to really understand the point here. It's possible to test here what's happened, and after that, go there, the simulation, understand all the points. Point A, 100, works. Hello again, because it's in forever. And B, the capital letter V. Okay, works. Okay, it's good. But maybe this works with a physical device. Let's try. I show you, I need a USB, a micro USB. I have a connection here, a cable here, and put here, and a USB in my computer. Oh, you can see the light here, red. Yeah, red is connected. We have power in the microbit. Okay, so you go here, connect device. It's necessary to connect the device in the computer, show the information in the computer. Okay, next, pair, go here and connect. Sometimes the problems happen. It's usually like the problem like this. It's not usual for the Microsoft Windows, but my system is Linux. And in this case, sometimes something doesn't work, okay? And Mac and Windows works very well directly. Sometimes maybe it's possible a problem, and the idea how to solve this problem. If the connect doesn't work like this, a good idea is download the file, okay, download the file, okay, and after that, I go to the microbit, because the microbit, it's like a USB device, yeah, an ordinary USB device. So you go to your download folder, take the microbit webinar.x, yeah, X this file, and put in the USB device. It's idea. Maybe it works. And for now, it's possible to see here in my device. Probably we have a little problem. No, it's working. It's okay. So it's possible if I press the A button here, you see 100. If I press the B button here, after the hello, capital V. Okay, you can use. Okay. Okay. Another thing you can do here is press A plus B. It's possible too. Again, button A, and the color is something wrong because button A it's already done. Button B too, but I can use button A plus B. It means in the microbit, like this guy, I can press A or B or both in the same time. And it's possible to coding, to programming the both at the same time. Okay. And you have many others input selection. For example, it's possible to shake. You know, the microbit have accelerometer inside. Accelerometer like a smartphone. So the idea, it's possible to shake this guy, to do something. For example, a good idea. You can make a dice, or ordinary dice, to short a number for us using a microbit. Let's do this using the shake. Let's all this thing in the trash. I clean up my station and I start on start only to inform something. Icon again. My face. I like this guy. Okay, on start. This is it. After that, I use on shake. It means if you shake your microbit, something's happened. What's happened? The idea, it's used like a dice to short a name, a random number, okay? To short a random number. So use a shake. It's a good idea. Usually you shake your dice and okay, it's 6. Oh, I win. You know, this is the point. And of course, you need to show a number. But if you put like this number 0, all the time, if you shake out the simulation, you have the button shake. It's only the simulation, because in the original device, in the physical device, shake is shaking. Shake, shake, shake. It's like a music. So if you shake, show 0. Because the number is 0. But the idea is not show only all the time the number 0. It's not this. It's to show a random number. It's not only one number. It's a random. Random, the idea of randomship is math. So you use until now the basic blocks here. You see on star, forever, pose, show number, show icon, see, basically, and input to press A, to press B, to shake. We have many other inputs possible here, but we have more information because here we have the block about music. You can see the melody, the music which I have, the tone I want, and C or D or E, and so on. You can have the LED of in this LED here, of course, radio to connect the radio, and loops up. You have math. The point here to do in this point, it's the math. So let's do, where's the math? The random. Pick a random 0 to 10. It's a good idea. So on shake, the microbit will show a number picked randomly from 0 to 10. But from 0 to 10, it's not a good idea for a dice. Usually on dice, we use the number from 1 to 6. The ordinary dice is like this, you know, a face with 1 dot, another with 2 dots, 3 dots, and so on. So usually a good dice. Good is not there. It's a good dice. It's 1 for 6. So now I have this microbit programming in a shake 6, shake again 5, shake again 6, shake again 2, again 2 again 1, 3, and so on. Each time I shake, I have a different number. It's amazing. Of course, it's possible to use a different dice. You know, a dice used by a rolling play game, RPG. It's possible to use a dice. In Brazil, you said this dice is a D20. Probably in English too. In this dice, the number is from 1 to 20. It's a icosahedral. I love this name. So now, in this case, I have a different dice. It's a dice for RPG too, and check the number is 16. Again, 60 again. Now it's 4. Now it's 11. Now it's 14, and so on. You see, it's really directly. And again, let's try in our physical device. And we put here and here. Okay. Connect device. It's working tonight. Today, not yet. Sometimes it's terrible to do this in Linux. Sometimes I love Linux, but sometimes we have really problems. No big deal. Go here. And transferring. It's okay. You can see here, if you shake, change the name, the number. Of course, it's upside down because I don't have a cable bigger enough to change the image. I try one, but the micro USB, it's not usual for now. I have many cables here from USB-C. Where's, yeah. So the idea, it's to see, the idea it's shake and have something to do. Okay. Of course, the image it's not very, very good.
Vinicius,
Yep.
maybe to show the controller, it's better to stop sharing because we cannot see the camera. It's very small. So if we just show
It's
again,
a good idea. Yeah.
so
Maybe it's a
people
good
can see
idea.
better. Yeah.
Like this. Where is this guy?
Yeah. Now
It's
we
better?
shoot and yes.
Yeah, the idea
You
is
can-
shake the microbit and
it starts.
we have a different number
Yeah.
all the time. Of course, not all the time because it's a random, and sometimes it's possible to short the same number. Statistical possible.
But if you can move to the more to your right, to the other side, yes. It's number 2.
15.
15.
I
9.
think 6 now. No, it's upside down.
Okay, it's upside down. Okay, good.
Yeah,
okay.
this is 6. 20.
Okay, good. Okay.
Okay, it's only
Yeah,
to understand it's possible.
Yes, just remember if you want to show
Yeah, it's
the
a good idea.
microbit, you stop sharing. Okay.
Yeah, it's a good idea because it's I see directly here, but in the website, of course. So it's possible to do a dice with this. Okay, it's good. But the same way, it's possible to control something here. Let's change. Again, button A. If button A is pressed, for example, I want the pin, that's it, the pins, you see here, pin, I want to control this guy now. The pin, the digital pin, right, 1. It means if I connect a LED in digital pin 0, for example, if I press a button, the LED is turned on. Direct idea. Copy, Control C, Control V, it's direct copy, and change to B. You see here, A, turn on the pin 0, this one, and B, make 0. It means turn off the pin 0. So it's possible directly, very quickly, programming something to control a LED, for example, like this. Of course, in this simulation, we don't have LEDs here, but I can understand what's happened. If I press a button here, the pin 0 change the color, you see? Because now pin 0, it's on. If I press button B, P0 turn off. So the code, it's working. You see? The code, it's working. The idea is take the physical device here to try all my connection, because the microbit, it's two things. It's coding like this, but at the same time, it's uses something physical. You see? So what's happened? In the 3V here, it's the power. I need to connect something. You see, you have the 3V here. I will change. Stopping here. Okay. So in 3V, I connect this connection here, the alligator, like this. Okay, like this, in 3V. I put this other one. Now, to use this one, I will change the point, connection direction, because we don't have many times. You connect directly, the red one. I have a green LED here. And to see the LEDs, it's important to understand you have two legs in the LEDs. A long one, a short one. The long one, it's always the positive, and the short one, it's always the negative. Okay, and when you connect in the microbit, the ground, you see the ground, G and D here, it's the negative. So this guy, I will connect in the short leg. Information in our code, it's in 0, pin 0, here, pin 0. So in pin 0, I take the alligator here. This is the information, and this LED, it's only information positive is the same thing. I connect to the longest leg, okay? So I have this connection really directly, and like this, okay? Now, come back to the website and share the website, of course, to connect my microbit here and transfer this code using the button A and button B. I know we have a problem here. Okay. Transfer. This is it. Okay. So let's go again. This is my, oops, again. The microbit is here. The microbit is here. And the LED is here. Okay. The LED is turned off. It's off. You see? If I press the A button here, turn on. B button, turn off directly. You see, it's possible to control a LED, turn on in A, and B, turn off. Or B, it's always turn off. And A, turn on. It's possible to control a LED like this. I have another LED here, and it's 3 volts. So it's not big deal. It's possible to take the hand here. We don't have current to be dangerous for everyone. And now I have this other LED here. Again, the short, it's the negative, the black in my situation, and the longest is the positive. Again, where's the oops? You see? What's the difference? Now it's a yellow LED. Yellow LED needs exactly 3 volts. The microbit furnish 3 volts. So it's perfect for yellow LEDs. Turn off, turn on, turn off. It's perfect. Okay. The other one, it's a green one. The green is necessary something about 4 volts. So we don't have power supply for all the LEDs. So the brightness, it's not so good like this one. You see? But the control, it's here. You see? Of course, all this thing, it's really basic here because we don't have time to go deep and deep, but it's really possible. You have many tutorials there. Of course, you can mail me something to understand more and more about it. It's possible, for example, use a circuit here. It's not a circuit, this is only a connection, but I can use this guy connector here and use, for example, more LEDs to control many LEDs. Okay, but the idea, it's only 3 volts. If you need more power energy, you need to use another source of energy. The microbit furnish only 3 volts. Okay, but we have many things to do here. It's possible. You can see. Today you use a LED, two kinds of LED connected directly in the microbit, and it works very well. You use the microbit like a dice and understand the point. And all this thing it's possible using coding directly in this guy. For example, let me show you. I have, for example, here a compass. Okay, I did this before. Okay, it's not now. This is the code. It's possible. It's not a really complex code here. And to simulation, we have this point. For example, 3 degrees. It's north. And 69, it's left. It's possible to use something more precise, you see? But in any case, directly, you have only 4 cardinal position in a compass. I know it's not only 4, it's 16, but you know, the first approximation you can do like this. And of course in the simulation, but if I download this information for my microbit here, it's possible to use the microbit to change the position like this. You understand where is the north, why? Because inside the microbit, remember the image in the beginning of this transmission, here we have a compass and accelerometer. Both it's available in smartphone too. The same device, the same little device here. And because this, it's possible to see where is the north and so on. And I have other things here. The asteroid. It's possible to create a game. Of course, in this case, you can see the code. It's a little bit more complex, but it's possible to do. Button A, button B, on start, and forever, all the information. It's here. And this is a game. So go, you can take. You see, I can change the position of this guy up. The asteroid touch my spaceship and game over. You see, game over and my score. After that, game over and score 2 probably. 1. Oh, terrible 1. So game over. Let's go. Change. Okay, okay. You see, it's a game. It's possible to do with the kids again. Directly, like this. You see, let's... I am perfect. A good pilot. Not so one. Okay, the idea in this code, it's easier, but you need to put more information. I know it's little teeny to see, but the idea, it's here. If I took the AB, it's a pose. Go, start. Okay, go. Oh, terrible. I finish. So I take this guy, pose. You see, because if A plus B, it's pose. If you touch the logo here, resume. You see? You can put anything. You can have score and lives and so on. The idea is coding using this guy, and after that, use the physical device, transfer to them, and use this guy. Okay. Of course, if you prefer, you can change for Python directly here. It's a good idea to use these blocks. Let's try simplest, this one, webinar for today. It's a really simple code. You see? So direct code and change for Python, for example, to understand the language, because the kids understand the blocks and after that, you can introduce something in Python or JavaScript. The website translates directly for these languages. It's a very good thing to start programming culture, for example, in the kids, I think. Gustavo, I have many times, not?
We just hit the hour mark.
Okay.
So if you, it's best if you can, walk towards the conclusion.
Okay, the conclusion here is using a device like this one, like microbit, like a device like this, basic kit. It's possible to use something like a basic kit have the microbits, the connections, one or two LEDs. Only with this, it's possible to use in the classroom for 1 year. You have many activities. Here, in 1 hour, I show you 3 activities directly, easy to do with the kids with 10 years old, for example. But it's possible use, I show you a game, it's possible to use a game, to use a gamification more precise. For example, we have another website, name it arcade. Let me show you. It's from microbit too. It's microbit arcade. The name is microbit arcade. It's like this. You need to go and sign into the something, the code. But in this case, is to use the microbit, to use the idea for blocks to create games, directly games, go a code of adventure. You have a many example here. It's not for only this guy. It's to use what you learn using microbit, code blocking, code by blocking, and after that, do the next step in create more complex games, more complex code, like in this situation here. So we have a lot of things possible to do. It's amazing world to use with the kids in the school, at home too, because it's really practical, and you can use any computer. You need only the internet access to go to the website. But if you are an expert, you can code in Python in your notepad in computer, and finish. If you are an expert, I prefer use the website. Okay, and we have another things to control. I can show you the electronic rotor here. You see, it's possible to control this guy using a fan, a little fan like this. It's possible to control a LED ring like this. All these guys is possible. You can buy in any electronic store. It's not. It's possible to have a good kit, with many things in microbit, with less than 100 euro, for example, really less than 50 years or less. A kit like this, a lot of things, amazing things to do. Okay, thank you, everyone.
No, wait.
Yeah.
Wait.
No. I'm here.
We have a question here by Paul Cruz. He's asking for the more complex activities like the game. He wants to know your recommendations. Like, do you recommend using the pseudo code first? So if you can just answer Paul Cruz, and If anyone else also have questions for Vinicius, now is the time because we're close to the end. But so what do you suggest for Paul for the complex activities? Pseudocode first?
Yeah, pseudocode, it's a good idea to understand the logical, the code logical to understand. I didn't show here the if, the for, the situation of the condition. It's the pseudocode, it's good to understand this point. Okay, but it's possible. Usually I did this. Go directly in the code by blocking like this and try something easier in the first and go deeper and deeper. It worked very well with the kids. It worked very well with the adults too. And you can use these guys. Pseudocode, it's excellent idea, but if you don't have time to go the pseudocode first and after that go to coding by blocking, Python and so on, go directly use the block, because many of others website, other things use these guys. For example, Scratch, it's another platform, very useful tool, and use this same guy, the code by blocks. So I think it's an excellent idea. The other question is about?
Oh, that's one.
Okay.
Let me see if there are any more questions, because there's a delay between our transmission here on Zoom and YouTube. But so far not. I don't know if Rosa wants to say anything before we close.
No, just would like to thank you both. Thank Vinicius for this nice presentation. I am itching to have my hands on microbits and do a few things. I really have to make some time in the schedule, in the agenda to do that. Thank you very much.
Thank you.
Those of you that are in Portugal, you can find Vinicius in our Makerspace, the chat, and participate in one of our live training here. I am sure that you also have the champions like Vinicius in your countries that can help you with that. And I would like to thank Gustavo, of course, for being the maestro here in this event. And to say that next week, we are going to have another webinar. As I said, the webinars are going to go continuously until December 20th. We have a small break, and then in January, we pick up again with a few more. And next week, it's going to be about electronics and programming with Tinkercad. So we will announce it shortly. We will be sending out to you a newsletter with this information and other activities that are coming your way soon. So thank you for listening.
And next week you'll be back on Wednesday, right?
You'll be back on Wednesday, same time, back on Wednesday. The thing is that yesterday was a holiday for several countries, including here, Gustavo. We had the opportunity to rest a little bit. But next week, yeah, we go back to Wednesday, the normal time.
The normal schedule, yeah.
Exactly.
Very well. So, Vinicius, thanks a lot for showing microbit to us, or some of us as a new thing. And it's indeed a very, very wonderful tool we can do lots of things with this little guy.
Yes, I think so.
Okay, so thank you everyone, and
thank you everyone.
See you next week with another webinar here on